Continuing, we will learn about converse of propositions to equivalent propositions. Firstly, we read some propositions to have a brief concept about our sections. Given triangle ABC, consider the proposition of the form P and 12Q as follows. If ABC is an equilateral triangle, then ABC is also an isosceles triangle, P and 12Q. Okay, and P, if ABC is an equilateral triangle, then ABC is also an isosceles triangle with an angle of 60 degrees. Do you know what is isosceles triangle? In geometry, an isosceles triangle is a triangle that has at least two sides of equal. So, and these are missions. State the corresponding propositions Q infer P and determine if they are true or false. Using the form Q entail P. To finish this question, we have the results. In problem A, ABC is an isosceles triangle, then ABC is also an equilateral triangle, Q entails P. And in problem B, ABC is an isosceles triangle with an angle of 60 degrees, then ABC is also an equilateral triangle. Next, we have to determine whether these propositions are true or false. Do you know what is an equilateral triangle? If not, watch my previous lessons and find the answers. I'll draw two angles. First angle and second. The first angle have two sides equal to each other and have two angles equal to each other. But the second angle has three sides equal to each other and three angles are equal to each other too. And every angle is equal to 60 degrees. Okay, 60 degrees. 60 degrees too. So this is called isosceles triangle. And this is called equilateral triangle. Vertex with three vertex. Okay, I add three vertex. A, B, okay, C, A, P, C, right. So determine determine if they are true or false. Firstly, problem A. ABC is an equilateral triangle. Then ABC is also an isosceles triangle, right? It's easy because an isosceles triangle just needs two sides equal to each other. So an equilateral triangle satisfies this request. But when we use the form Q infer P, ABC is an isosceles triangle, then ABC is also equilateral triangle. This is a false proposition because an isosceles triangle cannot be an equilateral triangle. In problem B, if ABC is an equilateral triangle, okay, then ABC is also an isosceles triangle with an angle of 60 degrees. So if this isosceles triangle has one angle 60 degrees, so because both sides equal to each other, so this angle is equal to 60 degrees too. And the sum of three angles are equal to 180 degrees. So the last angle is 60 degrees too. And it's become an equilateral triangle, right? But when we use transform Q infer P, it's become ABC is an isosceles triangle with 60 degrees. Okay, then ABC is also an equilateral triangle. It is true proposition true. This is a property of these propositions. Proposition Q infer P is called the converse of P into Q. That means P into Q is a proposition, and converse is become Q infer P. And you know what? The converse of a true proposition is not necessarily true. It's quite interesting, right? And I will give you some examples to make it more clear for you to understand. Okay, you can find a lot of examples in life. My example is, if the earth explodes, all of us will be died. It's a true proposition, right? But the converse, if all of us die, the earth will be exploded, is a false proposition, because people can die by many reasons, like disease, wars, or accident, and these things cannot result in the earth will be exploded. It's ridiculous. And this is our conclusion about this section. Read after me and focus on the size and simple. If both propositions Q infer P and P infer Q are true, then we say P and Q are two equivalent propositions. Then two equivalent propositions are denoted by P is equivalent Q. This is equivalent size. And we say P is equivalent to Q, or P is the necessary and sufficient condition for Q, or P if and only if Q. The books give some example first here, considering them with me to increase your understanding on this section. Example 5. Isosceles triangle ABC with an angle of 60 degrees is the necessary and sufficient condition for ABC to be an equilateral triangle. In P, a triangle is a right one if and only if it has an angle equal to the sum of the other two angles. So I will help you to prove the problem P, because the problem A I have proved for you. A triangle is a right one. A right triangle. What is a right triangle? A right triangle is a triangle with an angle E equal 90 degree. Okay, it's a right angle. This is a right angle, and a triangle is a right angle if and only if it had an angle equal to the sum of all the triangle. So I can put the A's P, C. So firstly, we have A plus angle P plus angle C equal 180 degree. So first angle A equal 90 degree. So we infer B plus angle C is equal to 90 degree too, and they are two equilateral triangle. So easy. We need the side angle here. Okay, I got it for you. Okay, so I will give more example. For example, we have x equal 3. So infer x squared equal to 9, right? But x squared equal to 9, we cannot infer x equal to 3, because we have two solutions. In this case, when x squared 2 equal 9, we infer is equal plus and minus 3. So they are not equivalent propositions, but I have equivalent propositions for you. For example, square root of x equal, so infer x equal 4. That's right. And when x equal 4, we infer square root x. So square root x equal to E equivalent x equal 4. It's quite easy. We are going to finish this part today. How much do you comprehend this part? Watch it many times until you feel it's easy for you to listen on the words and understand knowledge. And we will come to the last part of these lessons in my following lessons.